Welcome back to Computer Science 4303. Today is the last day of classes, and certainly I'm going to say last but not least, we have Mike Cook, who's a pretty awesome AI guy, and I won't do him justice in the intro. So, Mike, why don't you just say a little bit about yourself and what you do? And actually, before you get started, I'm going to talk about probably your really old stuff because we haven't seen each other in years because of COVID.
Yeah.
And it's like people, still come to me and talk about StarCraft stuff, which is stuff that I was really doing, like 8 or 9 years ago. I still do a little bit of it. So if I don't mean to offend you by talking about the things that I know you do, but feel free to talk about any of the new stuff that you've been doing at any time because I'm sure that's super exciting. But yeah, just talk about who you are, where you are, what you do.
I'm an AI researcher and a game designer. I currently work at Queen Mary University of London, where I'm part of the Game AI group. And I do research into automated game design, which I suspect we're going to talk a bunch about today, which is a mixture of procedural generation research and computational creativity. So getting AI to make games on their own and to think about what that means for creativity. Right now I'm working on a piece of software called Puck, which we'll probably talk a little bit about today. But actually it released today. I don't know if this is coming through on the
It
recording.
is.
My green screen just destroyed it. But Puck is a new piece of software I've been working on that designs games. It's exhibiting live in London right now, and I just put it online today. So I'll be able to talk to you lots about that today. But in the past, I've done stuff like make weird games that used the internet to generate their rules and made an AI that entered a game jam. I've done lots of like weird things like that are fun to talk about. I make games as well. They tend to be less successful than my research, but they're a lot of fun to do.
And what is your current position right now?
Oh, that's a good point. Yeah, I currently hold a research fellowship from the Royal Academy of Engineering. Essentially, that puts me at postdoc level, basically. But I've got a number of PhD students that I'm supervising and teaching some wonderful undergrad and master's students about computational creativity as well. So I do a bit of everything. Yeah, that's where I am.
That's awesome. And this is not meant in an insult in any way, but Mike's kind of the guy where if people are having a conversation about like experimental or crazy AI, like your name always comes up, right? And that's really cool because it takes a lot of guts to do the things that you do and sort of not hope that they work, but like get them to a point where they do work, right? If we'll get into what you do, but it's kind of crazy the things that you've been able to do, and I don't think a lot of people would take that sort of chance in sort of AI development. What I do is completely traditional in comparison. So I guess my first question to you talked about generative AI, and do you want to talk about a little bit like what was the original motivation? What was your interest there? What got you started in that field?
I'd been interested in games that generated things for about as long as I can remember. I didn't know anything about programming until I started my degree when I was 18. So when you don't have any knowledge about programming and you're like 10 years old, trying to understand what a game is doing is confusing. Like your mind makes up all these like metaphors and explanations for it. But I remember really enjoying playing games like Civilization 2, where it would generate a world map for you, and this would completely affect the story that you told. And you would, make up reasons for settling a city by this river. I got completely absorbed by the fact that every time I played this game, it was different. But I think the turning point for me to become a researcher was when I was doing my degree at Imperial College. I met Simon Colton, who was a researcher there and a lecturer. And he was building an AI that he wanted to be taken seriously as an artist. And he's still working on it. It's called The Painting Fool. And this was such a novel concept to me, the idea that a piece of software could be designed to be independent of other people and to do creative work on its own. And so a couple of years later, I asked Simon if I could do a PhD with him. And we got talking about possible projects. And at the time, I was going to do work on like all these like random little AI things, and I wasn't really sure where I was going. And then Simon, in one of our early meetings, just said that he'd always wondered if it would be possible to do the kind of stuff that he'd done for art, but for games, to build an AI that could design games. And I was just so excited to get started on that project. I remember I went to the train home for Christmas to my family, and I immediately started like hacking together things. I was just super, super excited to get into it. But yeah, I kind of grew up without any programming experience or much game design experience. And so I ended up kind of learning how to make games while I was also learning how to make things that made games. So it was kind of like a fun parallel development.
That's really cool. It's actually interesting. I think we had kind of a similar start then, where not so I also didn't. I mean, other than HTML, I didn't touch any programming until I was literally in my first university class. And a lot of people think like, oh, you're a prof, you must have been doing it since you were like 6. Like, no, I mean, I had a computer, but I was playing Quake, right? and EverQuest. I wasn't programming for sure.
Yes.
But then so I originally went to the U of A to do robotics, and then I took Michael Burrow's course, and it was in game AI. And I just fell in love with it. And at the end of the course, he said, "Does anyone want to work on StarCraft?" And I had been working with this other professor for a year, and I said, if I don't jump on this, I'm gonna just like regret it for the rest of my life, right? Like, how can you not do that dream thing? And so it was a little bit sad for a minute when I had to abandon a year of work, but then I had a 7-year PhD because of that. But I mean, it was like, it's crazy how one little thing like that can change your life so dramatically. You seem to have that same, like, prof says, hey, can we do you want to do something cool sort of moment.
Yeah, our stories are actually even more similar than I realized then, because I was also working with another professor for my final year project, and the expectation at my university was that's the person you do a PhD with. His name was Marek Sergo. He's a really wonderful guy and a really amazing researcher in AI and logic. But as soon as I met Simon, I just knew that like I had to do this. Like I had this had to be the field I went into. And I had to have that conversation with Marek as well, which was very sad. Marek was extremely chill about it and professional, but I personally was sad. It's funny as you say those little things. And I think that moment where you realize these are possible research avenues is really mind blowing. Maybe it's different for students who are sort of the age of the people in your class today, but where I'm always really impressed by the lives that young people currently lead. Like I spoke at a secondary school recently to sort of 17-year-olds, and many of them were already learning programming in their classes, and they even looked up some machine learning stuff. And I was thinking back to like what I was like on the first day of university, and it's just like incomparable.
Yeah, I mean, I met a high school student last year who had trained a neural net to like recognize their emotion with a webcam. And you think back when we started, like, that wasn't even possible.
Yeah.
Right. And now it's just a download. You can probably do it. I think you can do it in your browser. Like there's a JavaScript neural net thing that like, anyway. Yeah, it's crazy how things have changed. And the cool thing was for me, the thing I was going to do in robotics, 20,000 people were doing that. And so my life's work was going to be a blip like this, that XKCD comic where it's like, your life is expanding the circle of knowledge by like a pixel as a PhD student. Or you can be one of the first 3 people to do this StarCraft stuff. And to me, I mean, selfishly, I think it made me think that my thesis would be easier to defend. But also just, it sounded cool to work on stuff that nobody had done before. I don't know if that was the same for you.
Yeah, 100%. It's funny. I really appreciated your intro where you said that you think I'm one of the people who comes up when you talk about like weird stuff, basically. Because if that's the case, I'm very proud to wear that badge.
Mission accomplished.
So the university I went to prided itself on science and technology. It was Imperial College in London. It actually had no art students at all, no humanities students. It was a very weird place to be. And I was really into games. I was really into writing and journalism. And so I tended to like hang out with the weird people. Like all of the journalists were like also physics students. So we like would hang out in the basement and write the student paper together. And then the computational creativity people, which was the field Simon Colton was in, they were also like the weirdos. Like there was like, you're always in these groups where like, you're not like necessarily supposed to be doing what you're doing. And I think that's how games research feels sometimes in the AI world as well, right? But as you say, there's something really exciting about being the first person in the room. And it makes, I think when I was an undergrad, I used to think that would make it really easy. So we would look at like Turing in the late 40s and think, man, back then you could do anything in computing. Like it was so easy to come up with things. being the first person in the room is really hard in a lot of cases, because you have absolutely no groundwork to go on. You have no direction whatsoever. You have to make everything up. But at the same time, as you say, competing with 20,000 people for these big conferences, of these big problems that everyone's working towards, and you have like a fraction of 1% chance that anything you do will matter. It can be really satisfying, and I totally understand why some people do it. But for me, I love going out into the weird unknown, where no one really necessarily wants to do the things that we're doing, but we go and do it anyway because we think it's fun, and we often find really cool stuff. I was actually in a meeting with one of my PhD students just a couple of days ago, and they said to me, I'm really not sure if this idea is actually worth doing, and I'm worried because no one's done it before. Maybe that means it wasn't a good idea. And I said, I always feel like those are the ideas that I want to do the most, because and I think lots of games researchers are like that.
Yeah, definitely. And you made a good point there. It's kind of, all these people back in the 50s and 60s, we feel simultaneously like they were geniuses because they were the first, but also like, how easy was it to get a sorting algorithm named after you, like in the 50s, right? There's no Churchill's algorithm or Cook algorithm. There might be, but yeah, it's kind of funny. But just to sort of make this, reminiscing that we're doing now, because we haven't talked in a while, into a sort of lesson for the students, really, I think it boils down to don't fall into the sunk cost fallacy. Like, if you're at like a job or doing a project and you have a little bit of time into it, but you think something else is like your dream, my God, go follow that thing, right? Now, I mean, if you're 2 weeks away from a degree, don't quit just because, like, you think you might like this other thing. Finish the things that you've started, but don't, if you've just started something and you feel it's not right, you can always change. And for me, it worked out to be the best decision I ever made, right? So,
yeah, unless me and Dave are your PhD supervisors and you're 3 weeks away from submitting your thesis, and then you absolutely should not change course. You should finish what you're doing. But everything else is fine.
Yeah. Cool. So how did that all turn into the project that I know about? So Angelina, which is an AI system that makes games. Maybe you don't want to start there yet, but please continue talking about how that came to be, because that was the thing that, like, one of the things that impressed me most about like going to these conferences was seeing what your contraptions came up with.
Yeah, that was I got very lucky in a lot of ways, because I managed to work on broadly the same research project for almost the last decade, really. I've just sort of moved it in the direction I wanted to. And often, for many reasons, especially during a PhD, you kind of have to move around a bit. But I do feel very fortunate there. So at the beginning, as we were just discussing, I really had no idea what to do. And one of the first things I was trying was like, okay, well, how do we randomly design a game? And I was having the system randomly spawn objects on a screen and then randomly assign key presses to random effects. So basically, you wouldn't even know what button to press on the keyboard when the game started, because I didn't even know how to do a research project, much less design a game. And it was at that point, the problem just felt impossible. I was looking at these things and I was just thinking, how on earth can you possibly do anything here?
And Mike, just to give a little more context to people who aren't familiar with your work, so we're talking about a system that Mike made that makes a game from scratch, right? Like,
right.
You don't put in even the game mechanics or jumping or moving sometimes. Maybe there's an idea of movement, but like the assets, the goal of the game, talk about like, it's literally everything. It's crazy how much it makes of the game.
So different versions of Angelina ended up doing different things, and some of them were stronger at creating some types of game content than others. But the first one started out with a bit of help. So I read a paper by Julian Tegelius and Jürgen Schmidhuber, where they had made they had got a system to invent game rules, and they'd sort of evaluated it using machine learning, funnily enough. This was back in 2010, so that was before the machine learning boom. And I actually took some of their kind of framework for describing a game as an inspiration. And then I broke the game apart into several pieces. So there was the rules that described kind of when two objects touch each other, what should happen, that kind of thing. So there was I was providing a little bit of structure there. Then there was the physical layout of the game space. So I called this the level. You can think of like, if you look at Pac-Man's walls, like which places are solid, which places can the player go? And then what content should be in the game world? That was the third strand. So this was like colored shapes, and obviously they related to the rules. But if you imagine Pac-Man, you know, the small dots that you eat, there's many of them and they're all over the place, but there's only one Pac-Man. So, you know, there's a separate design task there. And I used computational evolution to try and design all three of these aspects simultaneously. So I used something called cooperative coevolution, which is a way of having an evolutionary system that is made up of multiple systems that can kind of all talk to each other. And so there was one system in charge of evolving a rule set, one system in charge of evolving the level layout, and one for the object layout. And the way that these would sort of, so the next question is sort of like, well, how on earth do you know when a game is good, given that that's several industries of people are employed to try and figure this out?
What's
on a daily
the evaluation
basis.
function for a game?
Right. Which is like, you know, an unsolvable problem in many ways. So what I settled on was having a bunch of different agents that would play these games in different ways. So some of the agents would just try and get the highest score possible. Some of them would avoid, they would have different levels of like risk aversion. So some of them would really try and avoid things that could kill them, like they would stay very far away from them. And some would just play randomly. And then we would use the results of these agent performances to sort of figure out what kinds of properties does this game have. So if a random player is as good as a skillful player, that might be a bad indicator. Not necessarily, but for the kinds of games I wanted it to produce, it was probably a bad indicator. So this basic structure, like this thing I've just described, I built many different versions of Angelina over the course of my PhD, but this structure of like breaking a game down into parts, evolving them separately, bringing them together to evaluate them using AI players, that was sort of like a process I repeated and refined throughout my PhD.
And what was the first game that your system made that you were like, holy crap, this works?
So the first version of Angelina produced some games with really unusual dynamics. One of them I think is called Revenge. I might actually be able to even screen share and
screen
show that
share
to you
at all time, and you will, just for your knowledge, you'll have the entire screen on the recording.
Okay.
With your image up in the top right here.
Will this work, I wonder?
Oh, I've got to give you, there you go. Now you can screen share.
Okay. This might actually be a little bit small, so I apologize if you're on stream. Maybe I can make it bigger.
Yeah.
It's not big on the screen now.
There you go.
Okay, fantastic. So this was a game called Revenge. I am the gray circle in the top left, which for the last decade has made it impossible to talk about this game.
Oh, Mike, sorry.
Yes.
I forgot to tell you, there's an option somewhere that has it optimized for video for your screen sharing, because it's chunky now. It looks like 1 frame per second sort of thing.
Optimize for video. Let's see if this works. Is this any better?
I'd need to see some movement there. Yeah, it's a little better.
Okay. It's not super important anyway that this isn't like a high octane game, but basically you move around this game. Anytime you're touching a blue circle, you gain points. And these red objects are moving very slowly, but whenever they hit a wall, they teleport somewhere, which means they can teleport like in front of you suddenly. And so you have to like kind of constantly keep dodging around while trying to gain as much score as possible. So it's sort of a weird game. It's not like it's not like an award winner or anything like that, but it was the first time where I thought, oh, I hadn't really considered that this would be in the sort of generative space that we described with the rules that we gave it. So we gave it kind of a catalog of rules that it could mix together and recombine and repurpose. But there was, this was the first time a game came out that was odd. And this would happen, more and more with subsequent versions of Angelina, to the point where, and maybe we'll get to that a little bit later, but there were times where I spent hours debugging what I thought was a mistake before I discovered that Angelina had just designed something that I hadn't expected. And this first version didn't do anything that extreme, but it was doing like really, really interesting stuff. And it was just, there's like a feeling when you when a generative system produces something for the first time and you think, this actually worked. Like all of these different systems, all of this theory and this hope had come together, and there was actually a thing that you could play that had a beginning and an end, you know?
Yeah, I remember, well, one of those moments for me was the thing that made me actually want to keep doing AI was when, so this Michael Burrow course that I talked about, the game AI course, or technically it was a heuristic search course, but he used games. And I made an AI that beat me at a game. And I was like, okay, this is really cool. And so it's sort of that same thing where I did some StarCraft thing in a simulator, and I spent 3 hours trying to debug why the computer had made this mistake before I realized it was actually just better than me. And I didn't realize why that thing was good. It was sort of the AlphaGo moment with that move 53 or whatever they called it, right? Where all the analysts were like, this is a huge blunder. Nope, it's actually just better than all of us, right? So it's kind of cool when you have those moments.
Yeah, it's a really great feeling.
So I always wondered, but never got around to asking you. So obviously, well, maybe it's not obvious. It would be very difficult to just tell a computer to make a game with no knowledge about like what a game is, right? It can't just flip infinite bits and hope that it produces an executable sort of thing. So you have to start with some sort of base knowledge, like human intuitive knowledge, or like you said, possible things that could happen in a game. Like you said, the red things teleport. At some level, that must have been a thing that you said was possible, or like moving up, down, left, and right. That's a thing that's possible. Can you talk about like what went into those initial decisions for those, and how did you settle on something that produced something that was like good but not too crazy that it wouldn't be understandable to humans?
Well,
okay.
So the later systems are testing the limits of what humans can understand, I think. But yeah, that's an interesting problem. So if you recall, I was saying that I also learned how to make games at the same time that I was building Angelina. And so what I would often do is I would pick a new genre that I wanted to test with Angelina to get it to design. Like, for example, platformers or Metroidvanias. And then I would make some prototype games myself, like some small ones. In computational creativity, we call them inspiring examples. So they're like things that you're making that you would like your system to be able to make one day. And through doing that, I would kind of learn myself what was involved in making a game like this. And I'd also begin to build up little chunks of like game concept in my head. So for Metroidvania, you'd start to implement little mechanics like lock and key, like items that change how you can double jump or triple jump and that let you reach new areas of the level. And you start to think about like how you could expose these in a grammar that a system could use. So for the early Angelinas, that was sort of the route that we went down. My favorite system that I built, though, actually went completely off-piste with this, which was called Mechanic Miner, which has since very recently worked its way back into my research, but it's not like fully developed yet. So I'll talk about the old version. So previously I'd always, as you say, kind of built these little jigsaw pieces of rules that the system could put together to make full game mechanics. But for Mechanic Miner, I really wanted to ask this question of, okay, but how would you do real invention? Like, how could you invent game mechanics like a human developer does? And so I had the system just generate code, like raw code, with no understanding of what the code might do or what problems it might cause. For Mechanic Miner, we limited it to when you press a button, search for a variable somewhere in the code base and modify it in a particular way. So it's not like loads of lines of code. Mm-hmm. Mechanic Miner was just single lines. And then, of course, the next question is, well, is that a game mechanic? Like, how can we test if this code you've generated is a game mechanic? Because 99% of the time, it's not going to be. So what we did was we designed a level that was unsolvable. So imagine a Super Mario level with a huge wall in the middle. And we basically said, okay, every time you invent a new mechanic, load it into the game and try and solve this level using the mechanic. And if you get further than you have before, like if you complete the level, or even if you get halfway through it, that must mean that this code you invented did something new. So this system was one of the wildest systems I've ever made because it could do anything it wanted. It could like delete half of the code base or like crash the engine. I would have to catch every possible exception the code could throw and just ignore it, because the mechanics were throwing exceptions left, right, and center. But it would find incredible mechanics that I'd never thought of. And it even found like experimental features in the engine that weren't documented that I didn't know about, and it would modify them. So the engine I was using was Flixel, which at the time was really popular. And they had an experimental feature, which was elasticity, that changed. It basically made something bouncy. It made something as if it was made of rubber. And this system found that if you change this number away from 1, you can like make the little game character like bounce higher and higher and higher, and eventually they can bounce over the wall and reach the game exit. And so the system was actually like coming up with new concepts without me needing to give it a jigsaw of rules. So I've taken a lot of different approaches basically over the course of the research, and the fun thing about doing something like that is explicitly not useful to the games industry, right? No one in the games industry is going to want me to generate random bits of code and insert it into their code base, but it is really cool, and it was kind of inspirational, and it made me think differently about like how game designers could work. And so I really like doing, kind of, there's sort of two sides to this research, right? There's like the side that's actually potentially useful to human designers, and then there's the side that satisfies us as researchers and like weird code alchemists.
I do think though that even though something may not be immediately useful, right? This sort of thing, someone has to take those first steps for it to becoming useful, like someone had to make that first sorting algorithm, before other things could be built on top of it. So don't sell yourself too short about it being, quote unquote useful or not. So do you have, can you show this game modifying things? I don't want to put you on the spot for screen sharing. I'm not sure how much you have available there.
Yeah, I think I can actually show you. So what happened was, I had this system that, so one of the nice consequences of this system was it was able to, it wasn't just that it could generate mechanics, but because it understood how those mechanics were used, it could then generate levels that could only be solved using those mechanics. And so we used it to make a puzzle platformer called A Puzzling Present. And I think I might be able to hopefully, possibly share with you a little bit of game footage. Is this working?
Yes, it is.
So this is actually another YouTuber playing through the game. So I'll kind of skip forward and we can see a bit of gameplay. Hopefully they'll be good enough at the game. But what you can see here is this is actually essentially the test level that we used to generate these game mechanics. So you can see there's a wall in the middle. And in this case, the game mechanic that was invented was inverting gravity. So this is exactly like Terry Kavanagh's VV, which you might be familiar with. And this lets the player walk around the surface and then go back to the player. Don't think too much about why it's Santa and presents. It was near Christmas. I made some choices, and there they are.
And just to like let people know, it probably didn't generate this tutorial in text. Like it generated the game rules, and then you made a package around it, sort of thing.
Exactly. Yeah. So this was a little bit different to Angelina, and I had always hoped to pull this system back into Angelina, and I just couldn't find a way to do it until about a year ago. So at the time, I thought, well, how am I going to show off like this research? Because it was kind of in isolation. And I ended up deciding that I would kind of make this game. So the art is myself, and the level progressions are sort of a mix. The system designed the progressions, but I curated a few levels to make sure that they were actually solvable. So you can see these levels are use the elasticity mechanic. So you can see the holly is lethal. So the holly kills Santa if Santa touches it. And you can see the player is slowly making themselves bouncier in order to reach the present and complete the level. So these levels were designed by the system, but I kind of put everything together into a final result.
That's really cool. And this is one of the examples. So you did the sort of assets for this to make them human intuitive, but you have other examples where like, you use like Google images to produce potentially not safe for work results. I remember you generating a game live one time and just sort of keeping your fingers crossed that it was going to be presentable at a conference.
Yeah, I've had some good fun with that kind of stuff in the past where people often, like journalists would often ask, like, well, how long does it take to make a game, and could you make one for me now? But some of these systems, especially the later ones. So actually, this is a great segue, because the first few Angelinas used fixed assets, so they didn't really, they just focused on their own thing. But later ones started pulling information from the internet. So we made games about news articles. We had the software use like online knowledge bases. So it entered a game jam at one point by taking the theme of the game jam and then sort of breaking it into individual words and using semantic knowledge bases to like understand what that theme might mean. It completely failed to understand it basically, but people loved the output anyway. And as you say, like pulling down random art from the internet. And most of the time it was okay, but in particular, the games made about news articles, some of them like were pretty close to the wire in some cases. It would make games about news articles about war, and sometimes it would include just photos of the war in question. And I was not, at the time, I did not have any, because when you're planning these systems, and this is, now a major part of AI ethics, but when you're planning these systems, it's sometimes hard to think about the worst case scenario. You have to kind of train yourself to do it. And as a PhD student, one of the only ways you have of doing that often is to run sort of small experiments yourself and realize what can happen. And especially when you're using internet data, the kind of worst case scenarios are really hard to predict.
Yeah, and so one thing that I tend to say about AI is like, emergent behavior is scary for companies who have shareholders and stuff. Because like, even if the individual components that you did grab from the internet were all completely fine, but then you end up with a game where like group of people X is killing group of people Y. Like, this is not something that, anyone really wants released, because, it's really easy to look at something like that and say, oh, this was planned, it's racist or whatever, but it's, it can get scary. So you kind of have to like curate what you show to people, and you wouldn't want to be on a stage in front of 1 million people and just sort of let it go live, or at least be sort of fingers crossed when you do. But I mean, to me, that's also like, as long as you understand that there's like mathematics running, it's not intended to be bad, but it could produce something that's a little uncomfortable, that's the context in which it is. So, science.
Yeah, and some people actually really liked that about some of these systems. So I made a game called A Rogue Dream, which automatically themed games using Google autocomplete results. And it very rapidly became clear that this was going to be offensive. Like we couldn't stop it from being offensive.
Yeah.
But it wasn't offensive in the way that like talking to random people on social media is offensive. People described it as like playing a game against the internet. And sometimes it was fascinating in the way it thought about things, not so much the offensive stuff, which was just bad. But for example, if you said that it basically asked you who you were, and you typed in a word, and then it generated the rest of the game based on that. So a colleague of ours, Antonis Liapis, put in, I think it was goth or maybe nihilist or something as the player. And the health packs in the game became clouds of darkness, because goths love darkness. And like this kind of thing people really liked. But a children's museum asked me if I could make an installation version of this for them. And I basically told them absolutely not. Like there is no way I can make this safe. So, the projects have had like good sides and bad sides. And they've taught us a lot. They taught us a lot about this stuff. It's actually interesting nowadays, the way I solve this problem. So my latest system, Puck, is downloadable. It's the first time that you've been able to download one of my systems. And the aim there is that instead of trying to learn from the world, like from huge knowledge bases, the aim is that you will teach your version of Puck what you want it to know about the world. And so that means that it can learn what life is like in a city in Spain or a village in Germany. It can learn from the people around it, which I think is like, I'm hoping it will be an interesting alternative to that problem of how do you get knowledge into an AI system? It's obviously slower and less efficient, but it's kind of more personal maybe.
No, that's really
that's
cool.
my hope.
So something that I personally enjoy about AI is like architectures. Like it's easy enough to talk about, like, oh, I made a thing that makes games. But now I'm thinking, I'm sitting here, if I don't understand the architecture or the implementation of something, I go crazy until I understand how it is. Like I remember seeing something like on the street and being like, I don't know how that works, like some street performer, and then Googling and YouTubing like until I understand their trick or whatever. So I know we didn't talk about this beforehand, but is there any way that you can start or talk about like the architecture of how you actually make something like this, or even show a diagram or something if you do have something like that available? If you don't, it's fine. But knowing like that's what it does, but how it does it. So, and just for context for you, is that as a prerequisite for this course, the students do know a little bit about evolutionary computing. They did a genetic algorithm Sudoku solver, so they know a little bit about that. But and they know object-oriented programming and those sorts of things. But just how did you make it? It's like I think that's a really cool thing too.
Okay, so I think so. This has always been one of the interesting challenges with building these systems, especially because you have to build a system, you have to build a piece of software that produces ultimately another piece of software. And that was always a really massive engineering challenge, especially when I started working in Unity, because I honestly just didn't know how to have the Unity project output something that could be built as a separate Unity project. I struggled with this for a long time. So I think what might be, I'm torn over which bits to talk to you about or show you. So from an evolutionary perspective, I actually don't use computational evolution anymore, but or at least to the same degree. But that used to be a really interesting sort of architecture there, where so I think what might be most interesting is if I walk you through a little bit of how Puck works, which
Sure.
I can show you some of actually with again, fingers crossed if it's working, screen sharing.
And the only reason I mentioned the evolutionary stuff is because you had mentioned it already.
Right.
Yeah.
Okay. Fantastic. Okay. So if I hopefully this will, so this monitor runs at a ridiculous resolution, so you'll have to tell me if
I can see it. I can see Monday, January 1st.
Fantastic. 1999, if only. This is what Puck looks like when you run it. And one of the big differences that happens in the systems that I'm working now with, if you think about an evolutionary system, what happens is you start it running, it makes a population, it processes that population and makes successors and applies its fitness function and stuff, and then you get an output at the end. So you start the process and you get a game at the end, for example. We've now sort of moved into a different way of working with Puck, where Puck now never forgets anything it does. It keeps a record of every game it's ever tried to design, even bad ones, so it can come back to it later. So this is one of the things I always wanted to do previously, and obviously you kind of can do this with evolutionary systems in certain ways if you record everything you do, but this was a very explicit design choice. So I can actually show you what one of these files looks like now if we go over to this.
So just to let you know,
yes.
Okay. So I can read this text. I'm not sure how it looks once it's processed on Twitch, but on YouTube it should be fine. If you make it a little perfect, fantastic. That's great.
So this is what a game record looks like from Puck's perspective. And I've tried to record lots of information, including information that I don't necessarily think I'll need, just in case we find a reason to use it later. So for example, idea origin is not used at the moment, but this is to record whether this was a game that Puck invented, or whether it was a game a human showed Puck, or a game that it learned about from another instance of Puck, if we get them to communicate in the future. And it records also things like every time it's tried to play the game. So you can see here, this is a record of the players that tried to play the game. So this was a Monte Carlo tree search agent, which is a search algorithm for general game playing purposes. And this tells us like how it was configured in case we want to recreate the experiment. It played one round, which was a draw, although this was a single player game, I think. So it just means that it doesn't win. And its score was -11, which might mean the game isn't very good because a skilled agent wasn't able to even gain score, but not necessarily. So we record all sorts of things like what happened inside the game. So like each of these events corresponds to something like gaining score or moving a piece, in case we want to do analysis on that later. And then at the end, we actually have, I hope this isn't too disorienting to scroll down. We actually have a description of the rules. This is obviously really important because this is required to actually run the game. And at the moment, you can see these are using sort of, again, like a jigsaw set of mechanics. But elsewhere in the experimental branch of Puck, we have it actually inventing its own modules. So what I'm hoping is in the future, it will be able to have sort of two different modes of working. One where it spends its time coming up with a new game mechanic and then actually using it in game designs. And if we scroll down to the bottom, we just see some various housekeeping things. But there's also like other things like the date that it was invented, the version of Puck that invented it. All of these things are useful for different purposes. So the reason why we have all of that stuff, to go back to Puck itself, I can maximize that to maybe make it a bit bigger on the screen. The text is probably still horribly small. Sorry about that.
No, I can read everything on the screen there.
Fantastic. So you can see here that this game list is sorted. There's a set of ratings here. So at the moment, Puck has a set of metrics that I've given it that tell it roughly what to look for in a good game. But because it remembers every game it's ever seen and it never forgets them, it might be that months from now, years from now even, it realizes that this game here that is rated 602 in the list is actually a masterpiece. And it will be able to notice one day, oh, like my way of thinking about games has changed. And I've realized this game is really interesting. And
sorry,
it might
Mike,
shoot up the...
You've got some static there on your voice. While you're screen sharing, do you want to just disable your video? I think that may...
yeah, absolutely. Sorry about that.
No, it's okay.
Let me...
It just started like 30 seconds ago. Oh, no, it's back. Maybe you could mute and unmute just really quick.
I'm still not... I wonder if it's... Is it possibly to do with the screen share itself, maybe?
I don't know, but it just started and you've been screen sharing for a while. It's not super distracting, but I just wanted to see if that really quickly would fix it. So,
well, if I'll just show you a little bit more and then I'll stop the screen share anyway and I can kind of talk once you've seen it. So this is what Puck looks like when it's actually doing its work. So it will play games. You can kind of see what it's doing at the same time and see descriptions of games that it's running. And obviously these are only the features that it has right now. We have I want it to do a lot more. I want it to be able to actually play games that you've designed. And when we're talking about architecture, Dave, you asking me about architecture. So Puck itself is kind of like an outer layer, and the games that you're seeing are just one module inside it. So for example, I'm currently developing a module that will allow it to make sort of adventure games where you control a character and move around a space. Mm-hmm. And we can still reuse all of Puck's interface with the game ratings and this ability to watch it while it designs. We'll be able to reuse that, but have it design different types of game inside. So I'll stop the share now so I can talk more plainly.
Yeah, all the static is gone now. So it was the screen.
Fantastic. Share. Yeah. Okay. So the in terms of architecture, like this process has come a long way because we've gone from the first version of Angelina was just this fixed closed system that you pressed go. A couple of hours later, you would get a game out. You had no control over it. And now you can kind of watch Puck work while it's working, see what it's doing, ask it questions, about try and get it to explain why it thinks a game is good. And that understanding might change over time as well. You can even, right now it's a hack. It doesn't have an interface, but you could design your own game and ask it to evaluate it. So we've really changed a lot of the architecture over time and ended up pushing more towards interactivity and visualization, because over time, the thing I've become really interested in is not just kind of how good these games can be that it designs, but whether it can actually become like part of a creative community, whether it can learn from other people, whether it can teach other people, give feedback, give critique. And so that interactivity became a bigger part of the system's design. Having said that, I realize these games look very simple, but it's actually produced some fascinating games so far, even with this very limited tool set. So I'm really excited for sort of, its future potential.
And how long has Puck been around so far?
So this system, I've been building this system on and off for probably maybe almost 3 years now, because during the pandemic, I also started teaching for the first time and supervising students, and my free time for research suddenly changed somewhat, shall we say. But this version of Puck has sort of been living and designing for about 6 months, I would say. So I run it sometimes in the evenings while I run it on my laptop while I'm playing games, and I can kind of watch what it's doing. I don't have, I don't think I can show you any of it now, but if you're familiar with, let me actually just back up.
Yep.
So if any of you are musicians, which I'm not, you might be familiar with MIDI keyboards or launch pads. So this is designed for playing music, but each one of these keys lights up. And Puck can actually run on this, and you can watch it design games and play its own games on this as well. So my hope is that Puck will be able to sort of be installed in museums or like exhibited at festivals, and people will be able to like really play and interact with this thing rather than it being like a passive thing that lives on my laptop somewhere.
Oh, that's really cool. Is that I was just about to ask actually about Unity. So you made this switch to Unity. What were some of the reasons for that? Does that allow you to do things like running on this board or having a web client, or what were some of the reasons for that? Because I know that when I teach an AI class, one of the biggest questions is, you know, do I teach them this game engine or do I do everything from scratch? And there's pros and cons to everything.
Yeah, that's a good point. So one of the reasons was a very selfish reason, which you might relate to as a PhD student, which was I really wanted to learn Unity, and I thought, well, this will give me a good excuse. I can be working on my research and also kind of get a feel for how Unity works. But the bigger thing was actually being able to distribute the games. So I was really beginning to have trouble. So the first version of Angelina worked in this weird HTML library that stopped being supported. And then the second two versions worked at producing Flash games, which we all know how that's turned out. It's now quite hard to play Angelina's games. And so moving to Unity meant that I could actually output these games for a wider variety of platforms. I could output mobile games if I wanted to. And as you say, like being able to connect to hardware like this is quite difficult unless you work with an engine that's popular enough for people to write open source software for it. So there were a number of reasons there. You gain a lot of benefits. Unity has its drawbacks, but I think for me, some of those drawbacks haven't hit me quite as hard, especially because, for example, with Puck, I'm not trying to make the system as fast as possible or as efficient as possible. And so I don't need to worry too much about kind of overhead. Whereas if you were sort of training a machine learning system, obviously Unity has machine learning plugins now, but you might not naturally think of a game engine to do machine learning work in because you'd want something headless so that can work as fast as possible, Yeah.
No, it's great. And I had another question lined up, but I forgot it. What sorts of experiments have you been doing with people with Puck? Because I know that like one of the great things about Unity, like you said, is people being able to run it. And I remember, trying to send people version of my code and be like, okay, well, first you need this Visual Studio redistributable, and then just trust me that this exe doesn't take over your computer. So like what sorts of, I want to be able to interact with people more, but it's a bit hard when you're doing the more low level algorithm stuff that I've been doing. So I've actually switched to a lot of just like pure JavaScript stuff. Like one of my entire courses, actually the intro to AI course that I teach is in JavaScript. And some people may think that's sacrilegious, but it's like people can use it and see it and run the software, right? So how have you interacted with people, and what sort of data do you collect from people? Do you say, was this game fun? Was this game bad? You said something, offensive before. Is there sort of a questionnaire or a survey that you run with people?
So I've done a couple of things. So one is that I've actually managed to get like a proper research collaboration going for the first time, which has been really great. And I think that's a direct consequence of working with Unity because it does make it a little bit easier to get people on board. I had Mads Johansson from ITU Copenhagen. He was doing a PhD on juice and game effects. And he integrated his system into Puck and allowed Puck to automatically generate juicy effects for its games. And we did a little study there. So that's like one advantage of a different sort of outreach.
Sorry, what's juice there?
So juice in this context is things in games which add like little effects that make you feel like motion or impact or behavior. And yeah, so we kind of added it to some of Puck's games, and we wrote a little paper actually last year at AID about that. And in terms of doing studies with people, we've still actually been using the classic like Google Forms associated with like builds, where I've been sending out to people and kind of getting their feedback about how they feel interacting with Puck. But something which, again, I think I personally found much easier to do with Unity is that Puck has a mode that allows it to stream on Twitch. And one of the things we can do there is we can interact directly with Twitch chat, which means
nice.
Puck can ask Twitch chat questions and gather responses.
Twitch plays
and
Puck.
Exactly. I'm hoping in the future to get like live feedback from viewers about games that are being designed. We've also, of course, the flip side of the sort of like thing I haven't had to deal with before, but is new to me now, is that I'm not just distributing Puck's games, but I'm actually distributing Puck. So in the past, Angelina was something which only I had a copy of, and often people would ask me where they could download it. But Puck is now downloadable. So yesterday I had to think about what are the implications of exporting Puck and putting it on the internet. Like what things are in here that I've forgotten to disable or turn off, like weird experimental code that's going to crash people's computers. So that's been a fun experience too. And the number one problem I've had there, which I'm sure you and probably all of your students are familiar with the pain of, is I hate designing user interfaces. And then even when I do design one, I realize, oh, it doesn't work on this resolution or on this device or whatever. So Puck is a bit of a mess. It will work as long as you don't change the window in any way. But maybe one day I'll manage to hire someone to do the interface properly.
That's really cool. I think that releasing it, I know that for my stuff, like I wrote a big StarCraft bot, and it's fine to have, that spaghetti code that like you said, you aren't sure of what it does anymore. And, it's fine for your own research, because if you run an experiment and it blows up or does something crazy, well, you just leave that out of the paper, right? But something that honestly, really sincerely did make me a much better programmer and implementer of ideas was releasing things as open source software and allowing people to use them. Because like, you release it and then the next day 50 people did something that you didn't know was possible, and so it makes it better, right? So it really is an opportunity. It's a bit scary, especially with the scarier for the thing that you're doing, because the worst thing that my bot would do was crash. It's not going to display a bunch of weird paraphernalia on the screen, but it really does. I think it's a cool opportunity to take in that feedback and just make it like better overall. So don't be too worried about that. I think it's really cool. And then you have to get into like documentation and all that sort of thing that like us as researchers we're absolutely terrible at. But one of the really cool things, sorry, just to go back a little bit, was when you had all that data that you were keeping about playthroughs of experiments and stuff. That's not something that I thought to do for like 8 years of AI research. Because, the sort of the mentality of a grad student is, oh my God, I have to graduate, do this experiment. You have the results in a text file, and then the code just gets lost in the ether, right? And I remember one person saying, well, you should rerun the experiments with this variable. I'm like, well, that code, I don't know where it is anymore. It's only been 2 months, but like I wasn't using Git. I wasn't keeping records very well. And so it's great to see, more academic AI research get into that reproducibility, right? Or like record keeping. And it's really great to see that.
Yeah, I think another thing that's changed it for me is I recently took on a PhD student who used to be an archaeologist, and I've been talking to them a lot about history and preservation, and they're fascinated with Angelina and Park, and we've been talking a lot about what it means to like record the history of something. And I'm just thinking about like all of these cool things that Angelina has done in the past, which I now barely have records of. I might have screenshots that I've saved in some cases. If I'm really lucky, I might have exported a game. But lots of these things have been lost forever, and they don't always turn up in papers, as you and I know. You can only put certain types of results in papers. And so I like the idea that I'm keeping everything, because I don't know what Puck might find a use for in 10 years' time. And maybe some weird thing that was here will become the foundation of like some amazing invention. So yeah, it also has a really interesting quality to it, because I had to throw out a bunch of these game records because there was a bug in my MCTS implementation which meant all of the data that Puck had recorded was essentially wrong. So it was sort of, it's sort of almost like you're storing the past in these text files, and occasionally you find out that the past was wrong and you have to delete them. So they have like a really weird quality to them.
Mm-hmm.
It's a lot of fun. It's been a lot of fun building this one. Yeah.
And one kind of not final thought, but just something I also have been thinking about when it comes to your stuff. And I know you're not a lawyer. It's not to scare you with that intro to the question, but what about things like copyright? What if, like, you know, some popular video game company whose name begins with X sees one of your games and then like remarkets it as something else? Or what if you happen to generate a game and release it for free, and, you know, it happens to be another game that someone doesn't want released for free? Have you run into any sort of thing like that yet?
I've had to contemplate some of this stuff, especially now that other people can run Puck if they want to, which means you might download Puck today and invent a game and think this is great, and make it, you know, and try and publish it and make millions. And the only thing that I put on the website, I wrote an FAQ, and the one thing that I've said is the only claim we're making is that we don't, you know, I am not making any claim to anything that Puck makes. So I can't promise you that other people may not.
Mm-hmm.
I can't promise you that you're not violating someone else's copyright. But from our perspective, we want to give away, you know, we don't want to claim anything from anything that you and your Puck make. Now, in the example of a big rich company stealing one of the ideas, in some ways that would suck. Although I have said in the past that, like, I think the biggest crowning achievement I could possibly have in my career is if someone stole an idea off of one of my AI, because that would mean you'd made it, right? That would mean that the idea was so good that
Mm-hmm.
someone else wanted to go and take it away. So like in some ways it would be kind of sad and gutting, but I think it would also be like the first line of my obituary. You know, I feel like that would be like the best thing I ever did if someone stole one of Puck's ideas. So right now I'm sort of chilling, waiting for it to happen. Some of its ideas have been good, not quite blockbuster good, but who knows? Maybe in the future.
Yeah, I kind of liked that idea. I'm not sure which game engine it was, so I don't want to name one, but they said something like, it's free unless you make more than 100 grand, and then give me 10%, right? Something like that. So yeah. So at the end of all of these, I like to we're coming up on an hour now. I don't want to take your whole day. But like advice for students who are programming AI, who I know you're not an industry person, but any like ground level advice that you have for someone who may be like thinking about doing a master's, or is thinking about some crazy idea that they thought was too foolish, or anything like that for students in the course as sort of a send off for them?
So I think there's a few things. First of all, now there's never been a better time to get into games research or do more games research. If you wanted to take a master's or something like that, it's just such a good time to do it. Second of all, we need weirder ideas. We need weird stuff. Games researchers are the best people in the world to do this. And when you're a student, you'll never have a better opportunity to do something weird with games. And third of all, I think, kind of like you and I were saying earlier, I think I've completely forgotten my third point, which is maybe an appropriate sum up for the energy I've brought to my career. But I think what we were saying earlier was like being that first person in the room, doing something that feels a little bit uncertain. Like, don't feel that you have to go the way the rest of the wind is blowing. Like we've all seen what's happened in games AI research in the last 10 years. Like, the machine learning wave swept through and it's changed everything forever, but no one knows what the next 10 years is going to bring. So if you have a particular passion for like visual novels or rhythm action games, or you think that you can design a new type of AI to change the face of like real-time strategy forever, but it's a bit odd, like just go for it. Don't feel like you have to follow the route that everyone else is going, because now like you'll never be in a better position than you are right now to like have that free time to do something odd and do something a bit different. And the industry has a lot of weird startups and indie companies and things like that who are less rigid about how they hire people. So even if you are looking for an industry job, sometimes doing something a bit funky is as good a way into one of those too. So yeah, be weirder is the thing I would ask you to do, I guess.
That's great. Maybe they could be the next Mike Cook.
Oh, God forbid, but thank you.
All right. That's a great place to end it, I think, Mike. Thank you so much for coming in the class. And definitely last but not least, it was a great way to end the course, I think. Thank you so much.
I had a great time. Thanks, Dave. Thanks, everyone.